Hello, and welcome back to another episode of Neural Bridge. I'm your host, Tarush, and today we're going to be talking about an exciting new model drop of Range 1. Now, if you've been working in AI, LLMs, or tech in general, if you've used an LLM, let's just say that, you've used the work of a 2017 paper called Attention is All You Need. In this paper, both attention and the transformer architecture are highlighted and brought out. And these architectures are so critical to how modern-day LLMs work that if you took it away, virtually every single state-of-the-art LLM would not function. So the way you cite this paper is Vaswani et al. 2017, even though contribution was equal and author name was randomized. But the Ashish Vaswani of the Vaswani et al. Citation and the first author on the Attention is All You Need paper is one of the most respected scientists in AI in general. The reason for that is he quite literally developed the attention and transformer architecture. And if you don't know, GPT stands for Generatively Pre-trained Transformer. So the T is right there. So his work is incredibly critical for the entire space. And his work after leaving Google Brain, which is the lab which actually produced this 2017 paper, was to develop America's very first open source model. And he started a lab for that. It's called Essential AI. And recently, they released their model, Range 1. And Range 1 actually was briefly #1 new model in Hugging Face, and its benchmark performances are through the roof. So I'm very excited to walk you through some of the benchmarks and performances of this model and highlight the accomplishment that Vaswani and his team have made on this project. So let's walk through benchmark by benchmark, statistic by statistic, and explain the significance of each number. So first, let's talk about pre-training of flops. So flop stands for floating point operation per second. And what this basically means is the amount of computation required to train this model, to pre-train the model. So if you look at Range 1's flop performance as compared to other comparable size models like Qwen 3.8 billion, Qwen 2.57 billion, it's quite literally a fourth. So the training was very effectively done in a way that's highly impressive to see. But obviously, a well-trained model can't just be trained on less compute. It also needs to be trained very effectively to do well on benchmarks, as well as perform well in general as a model. So let's walk through some of these really incredible benchmark performances. And I'm going to clarify each benchmark as we go through. Let's first talk about MBPP+. So MBPP+ basically tests basic programming ability. So it gives short Python function writing tasks and simple specs, and you're just basically testing control flow, basic data structures, and correctness. And MBPP Plus is a harder version of the MBPP benchmark, and it has a much stricter evaluation. So here, Range 1, an 8 billion parameter model, I just want to keep re-emphasizing this, 8 billion parameters, is the best out of all of the models in its comparable size range that has been benchmarked. So it's a 75.7 performance on MBPP Plus as compared to 71.2, 71.7, all of these numbers. The big number that I want to highlight here is GPT OSS 20 billion. 20 billion. That's 2.5 times bigger, and it performs slightly less than Range 1 Instruct on this benchmark. So that should give you a little bit of an understanding. And by the way, I want to emphasize something else. These are all instruct models, meaning they have been fine-tuned to do well on the task. It's not like you're taking base models from many years ago and just expecting them to do well. You're actually taking the literally properly fine-tuned models for these specific benchmarks and comparing them against one another. So there's no unfair advantages from a timing perspective here. This is the pinnacle of how the model can perform on benchmarks. So MBPP Plus clears with Range 1 Instruct. And HumanEval, it is virtually the #1. It's slightly beaten by a Qwen 2.5 billion coder Instruct. Sorry, Qwen 2.57 billion coder Instruct. And HumanEval tests code generation correctness. And you're basically writing code to satisfy hidden unit tests. And HumanEval Plus just expands the test from HumanEval. So it's similar to MBPP Plus in that regard. But as you can see, the model performance here is fantastic. Big CodeBench, it clears all of these other models, some of which are bigger than it, right? There's Gemma 3, 12 billion, GPT OSS 20 billion. These are bigger models than Range 1. And Big CodeBench basically tests realistic SWE tasks, and it asks, and SWE stands for software engineering. It has multi-file, longer context coding problems, and it's asking for program structure, APIs, code comprehension, robustness. So it's very close to real dev work, and I would quite frankly say it is much harder. So one of the biggest focuses that I want to place in this video is the AIME performance, the mathematical performance. Range 1 is very good at math. It tests Olympiad level mathematical reasoning, and it's taken from AIME, which is an American Invitational math test. So it's multi-step. It's like number theory. It's just pure competition math. So it gets a 43.3, and I want to look at some of these other performances. 20.9 on Qwen 38 billion, 0 on Coder Instruct. To be fair, it was instructed for code, so that kind of makes sense. CodeStrill also gets a 0, which makes logical sense, right? OMO, so 7.2. Llama 3.1, 8 billion, 2.7. 18.8, 32.5, 46.7. Like, other than GPT-OSS 20 billion, again, a model 2.5 times bigger than it clears on benchmarks. If you look at MMLU, right? MMLU is just the STEM version of the MMLU benchmark. So it tests broad STEM knowledge and reasoning, and it just asks multiple questions across STEM. It gets an 82, and the only thing, there are only a few models that outperform it, right? There's Gemma 312 billion, GPT-OSS 20 billion, and there's Qwen 3 8 billion. So it's super close to effectively clearing. SuperGPQA. This tests graduate level scientific reasoning. It's similar to MMLU STEM. It's harder than standard QA benchmarks, and the performance here is like quite decent, right? It's only beat out by Gemma 3. It is beat out by OMO. It is beat out by GPT-OSS, and it is beat out by Qwen. But overall, like, it's a pretty good performance from a model that was so small in size. But I think now we come to the critical benchmark, the benchmark that is the standard for software engineering globally, right? When you tell someone about an AI software engineering benchmark, the first thing that comes to mind is SweBench. And the SweBench performance of Range 1 Instruct is next level. So they got a 20.8 on SweBench verified. That's compared to a 4.5, 0.5, 3.7, 0, 0, 1.8, 2.4, and 1.1 on Coder Instruct models, on models 2.5 times bigger than Range 1. And Range 1 is comparable to GPT-4o in performance, despite the fact that it is only 8 billion parameters. And this is a significant engineering accomplishment. Because GPT-4o is a pretty good model. For a while, it ranked very high on OpenAI's list of high-performing models. Obviously, now with the advent of reasoning and so many other new incoming innovations, it has fallen behind. But if you look at the sizes of the models comparing GPT-4o to Range 1, almost sounds bizarre because of the size difference. But at the same time, they're performing like neck and neck. So this is a clearly a very high performance benchmark. And if you look at the straight base models, right? Like, you're not looking at instructs anymore. Range 1 is still clearing on a lot of these benchmarks, or doing very close to number 1, right? MBPP plus, they're now at 70.6 as opposed to 75.7. So not even that big of a drop from instruct to regular. HumanEval 57.9. Big CodeBench 47.5. It's still clearing on Big CodeBench. Manurva Math is another math benchmark. It's 43.2, which is honestly like pretty decent. And if you look at GPQA Diamond, it's already like it's pretty like competitive in terms of its performance. I believe it's number 2. So in summary, we have here an 8 billion parameter model, 8 billion for tiny model, that is able to perform comparable to GPT-4o on SweBench, is able to have incredible performances on STEM, coding, mathematical benchmarks, across the board, doing super fantastic. So to me, this is something that, I was impressed but not surprised to see because of the acumen of the person and people who have been working on this model, right? Ashish Vaswani. So I cannot wait to see more out of Essential. Obviously, this is an 8 billion parameter model, so it is on the smaller side. But my belief is when they release a model of a significant size, bigger than 8 billion parameters, it will give a lot of the top open source models these days a run for their money. So overall, very impressive performance by Range 1, and I look forward to seeing what Vaswani and Essential are building. Thank you so much for watching this episode of Neural Bridge. If you enjoyed this video, please make sure to like, subscribe, leave comments, and thank you so much. I'll see you in the next one.